Welcome to this grade makeover explainer, where your master auditor is going to teach you exactly how to transform raw, sour math responses into absolutely perfect 5-star exam plates. Listen, if you're sitting for the Cambridge AS and A-Level Mathematics 9709 exams, you are in the exact right kitchen today. We are tearing down and completely rebuilding one of the most notoriously botched dishes on the entire math syllabus. I'm talking about topic 6.5, hypothesis tests. Specifically, we're diving deep into null and alternative hypotheses and significance levels. I am your host, and today I am playing the role of your chief examiner. And let me tell you, as an examiner, I cannot stand sloppy paragraph structures. I absolutely despise weak thesis statements, and it makes my blood boil when candidates completely miss the core command words. Today, I'm putting on my premium culinary grade critic hat. We are going to look at raw, bleeding, unanalyzed factual definitions that students leave on their exam papers, and I'm going to show you, step by microscopic step, exactly how to cook them down into clear, undeniable, maximum yield arguments. We have a lot of ground to cover to get your exam technique up to a Michelin star standard, so let's fire up the ovens and dive straight into this.
Here is our rigorous prep list for today's audit. We're starting with the raw exam ingredients, then inspecting some truly sour responses. After that, we'll master the method mark strategy, perfect our exam methodology, and finally, we'll execute the 5-star final plating.
All right, Section 1, the raw exam ingredients, defining your core mathematical elements.
Okay, let's get one thing straight right off the bat. You cannot bake a cake if you don't know the difference between salt and sugar, right? Well, you absolutely cannot secure top-tier marks in Cambridge math if you haven't mastered the foundational theoretical architecture of hypothesis testing. Before we even look at a number, let's talk about your base ingredients, the null hypothesis, which we call H0, and the alternative hypothesis, H1. These aren't just arbitrary labels, they are the foundational starting points of any significance test you will ever run. The null hypothesis represents the status quo. It's the assumption that there is absolutely no effect, no change, or no difference in your population parameter. The alternative hypothesis, that's the exciting part. That is the actual claim you are trying to find statistical evidence for. Now, why am I stressing this so hard? Because the Cambridge Principal Examiner reports explicitly warn us year after year that candidates consistently hemorrhage marks by dumping raw, unanalyzed factual definitions onto their exam papers. They confuse these key terms. Or even worse, they'll write them out mathematically but completely fail to define the population parameter in the real-world context of the specific problem they're solving. Establishing exact context-specific terminology is your absolutely crucial first step. If you get your H0 and H1 wrong, or if you leave them vague, your entire dish is ruined before it even goes into the oven. The examiner is already docking points.
Now take a look at this matrix. This acts as our live Michelin dashboard for today. It dynamically tracks the 3 assessment objectives, or AOs, that examiners are meticulously monitoring when they dissect your text. AO1 is your knowledge and understanding. Simply put, can you define the hypotheses precisely? AO2 is application. Can you apply causal relationships and significance levels accurately to the data? And AO3 is analysis. Can you integrate this logically across the rest of the syllabus? To really illustrate how things go wrong here, let me introduce you to 2 apprentices I had in my workshop recently. Let's call them Alex and Sam. Now, Alex is the kind of cook who drastically overcomplicates the recipe. He panics and dumps massive piles of raw, unanalyzed AO1 knowledge onto the page without ever cooking it down into a clear argument. He'll give you the exact textbook definition of a significance level, but he won't actually apply it to the specific data in front of him. He completely misses AO2. Sam, on the other hand, is a fast cook. She rushes the preparation steps. She creates these beautiful, flowing sentence presentations, but she completely forgets to include the core mathematical ingredients. She drops the specific context demanded by the question, failing the AO3 analysis. Both of these approaches lead to completely disastrous, low-scoring exam plates. We need to find the balance between Alex's raw facts and Sam's rushed execution.
Let's move to Section 2, Inspecting Sour Responses. It's time to break down the anatomy of a dropped mark.
All right, step right up to the pass with me. Notice the stark, undeniable contrast here between a ruined, sour dish and a perfect 5-star plating. A sour response from a student reads something exactly like this. H0 is that the mean is the same, H1 is that it changed. The test statistic is in the critical region, so we reject it. I want you to really critically think about that raw, bleeding paragraph for a second. Where are the variables defined? Nowhere. What is the population mean, mu, actually representing in the real-world context of the question? We have absolutely no idea. The mean is the same as what?
It is a raw, descriptive paragraph completely lacking any command words or context. It instantly drops 60% of the available mark yield. Now, cleanse your palate and compare that to a true 5-star plating. Read this. Let mu represent the mean battery life in hours. H0 equals 45. H1 equals 45. At the 5% significance level, since the calculated test statistic of -2.34 is less than the critical value of -1.645, there is sufficient evidence to reject the null hypothesis. We conclude that the new manufacturing process has significantly reduced battery life. Wow! Do you taste the difference there? The 5-star plate builds a direct, bulletproof analytical logic string. It is perfectly seasoned with explicit context. We know we are talking about battery life in hours. It clearly sets up the 5% significance level. It uses comparative connectives, directly comparing the -2.34 test statistic against the -1.645 critical value. It hits AO1, AO2, and AO3 completely flawlessly. This is what examiners are desperate to read.
And look, this isn't just my culinary opinion as your host. This brilliantly illustrates exactly what the top brass are shouting from the rooftops every single year. As the Cambridge Principal Examiner reports state outright, candidates consistently confuse key terminology. Always define terms before using them in extended responses. Listen to me. Confusing these critical terms, like mixing up your test statistic with your critical value, or completely failing to state the significance level you are testing against, is the mathematical equivalent of actively poisoning your dish before it even reaches the customer. It shows the examiner a fundamental structural lack of precision. You are practically begging them to take marks away from you. Let's break down the top 3 toxic exam mistakes that examiners see constantly, the ones that will completely ruin your presentation. Number 1, forgetting proper format and conventions. This sounds basic, but it happens all the time. This means writing H0 and H1 without the proper colon, or writing a lowercase p instead of the proper population proportion symbol. It's sloppy kitchen prep. Number 2, failing to check format and presentation. This is when your mathematical working is so erratic and scattered across the page that the examiner literally cannot follow your logic string. If they have to hunt for your p-value, you've already lost them. And number 3, absolutely the deadliest poison of them all, writing answers that are not specific to the given context. If the exam question is explicitly about the yield of a chemical process and your final conclusion just lazily says reject the null hypothesis without ever mentioning the chemical yield, you are leaving massive high-tier marks on the table. You are serving an unfinished dish. You must avoid these 3 toxic mistakes at all costs to secure those top marking bands.
Moving on to Section 3, the method mark strategy. This is our heat control formula for the exam room.
Here is a massive secret about Cambridge mathematics. Systematic processing actually secures you points even if your final numerical calculation gets slightly burned at the edges. By strictly following this 5-step procedural framework, you ensure your facts and your evaluations blend flawlessly. Let me bring you back to my 2 apprentices, Alex and Sam. I put them under a strict simulated timeline condition in the workshop to see if they could salvage a broken response. I started the clock and it was chaos. Alex, true to form, immediately starts trying to overload the layout with heavy terminology. He's sweating, looking at me, saying, "Chef, we need to talk about type 1 and type 2 errors right now. We need to bring in the central limit theorem." I literally had to slam my hand on the prep table. I said, "Alex, stop. Look at step 1. Identify key elements and definitions first. You haven't even defined the significance level alpha yet, and you're trying to write a thesis on error types." Meanwhile, Sam tries to skip straight to step 4. She's hammering away on her calculator, and she says, "Look, I'll just punch the numbers into the normal distribution formula, grab the p-value, and write the final answer. Done." I looked at her and said, "Sam, where's step 3? Execute analysis with clear working. If you just drop a magical p-value onto the plate with absolutely no mathematical working shown, the examiner cannot and will not award you method marks. You are throwing away your entire safety net." It took some yelling, but they finally learned that by systematically moving through these 5 steps, identifying the terms, applying the principles, showing the clear working, verifying the numbers, and presenting the format, they were building an undeniable, unbreakable chain of logic. That 5-step process is the ultimate recipe to salvage any broken text block.
Kitchen freeze. Stop whatever you are doing right now. Drop your pens. I am looking directly at you. Before we unlock this 5-star paragraph structure to completely transform your final grades, you need to optimize your revision recipe. Take 1 second right now to subscribe to Ace the Exams at the handle @ace-the-exams. And make sure you hit that notification bell. You do not want to miss our weekly grade makeovers, whether you are cooking up results at IGCSE, O-levels, or AS and A-levels. We are here to audit your skills and get you those top marks. All right, mental reset over. Let's get back to the pass.
Welcome to Section 4, Perfecting Exam Methodology. Step into the interactive taste test arena.
I am handing the tools over to you right now for a live compliance audit challenge. I want to test your visual ingredient scanning skills under pressure. Challenge 1, the visual ingredient scan. I am starting a visual countdown clock in my head. You have a few seconds to scan this matrix and extract the single highest value data trend. Look at the analytical approach on the left and look at the mark yield on the far right. What guarantees the maximum mark? Go. And time is up. If you scanned this like a chief examiner, you instantly extracted the fact that explicitly linking cross-topic connections and fully justifying your differences guarantees the maximum mark yield. You simply cannot afford to just be descriptive in an A-level math paper. In the context of a hypothesis test, being evaluative means you don't just state that the test statistic is in the rejection region. No, you explicitly link that mathematical fact back to the real-world claim being tested, and you fully undeniably justify your final conclusion using comparative connectives. That is how you hit maximum yield.
Let's keep the pressure on. Challenge 2, spot the poison sentence. I want you to read this medium-tier student response. The null hypothesis was rejected because the numbers were too low compared to the alternative test. Take a really good look at that. What is fundamentally wrong with this? Honestly, it makes my blood boil just reading it out loud. As your master auditor, let me point out exactly where this sentence's complete lack of proper terminology destroys the structural precision of the entire score. First of all, the numbers were too low? What numbers are we talking about here? Are we talking about the p-value? Are we talking about the test statistic, the sample mean? This is incredibly vague, raw, unanalyzed AO1 material. The examiner is cringing. Second, look at the phrase, compared to the alternative test. Listen to me carefully. There is absolutely no such thing as an alternative test in this mathematical context. You compare a test statistic to a critical value, or you compare a p-value to a significance level. You do not compare numbers to an alternative test. This sentence's complete and utter lack of contextual evidence and proper terminology drops the overall score to the absolute bottom band. It is a poison plate, and we are sending it back to the kitchen.
Finally, Section 5, the 5-star final plating. It is time to max out those Michelin meters.
After a lot of blood, sweat, and tears in the workshop, Alex and Sam finally managed to plate up a beautifully transformed response paragraph, and we watched their Michelin dashboard meters max out to a perfect 100%. To master the syllabus topic and consistently achieve that level of perfection yourself, you must absolutely internalize these 3 universal exam rules. Rule number 1, the 3-step ingredient prep. You must accurately decode your ingredients from the question. Are you dealing with a one-tailed or a two-tailed test? What is the specific significance level? What is the exact population parameter? You must decode and define these explicitly before you calculate a single thing. Rule number 2, the heat control formula. You have to paste your method marks. Show your standardization formula clearly. Show the explicit substitution of your sample values into that formula. Even if you panic and press the wrong button on your calculator at the very last second, demonstrating the correct analytical process guarantees that you pick up those vital method marks. And rule number 3, the pass line review checklist. This is your final format verification. Before you drop your pen and move on to the next question, you must critically evaluate your final sentence. Does it directly answer the original question in plain English? Is it supported by your mathematical evidence? If you follow these 3 rules, your exam methodology will be unbreakable.
And that brings our grade makeover audit to a close. You now know exactly how to prep your variables, paste your method marks, and format your final logic string perfectly. But before I let you leave my kitchen, I have one final provocative thought to leave you with. We have spent this entire session mastering what happens when you correctly reject a false null hypothesis. But what happens to your data and your real-world conclusions if you accidentally reject a true null hypothesis? The consequences of a type 1 error are a recipe for a completely different kind of statistical disaster, and it's something you need to be prepared for. Keep your definitions precise, control your methodology, and never stop auditing your own work. If you want to keep elevating your grades, subscribe to Ace the Exams at Ace the Exams right now. Click that notification bell for our weekly grade masterclasses and drop a comment below telling me exactly which Cambridge subject and level, whether it's IGCSE, O-Level, AS, or A-Level, you want us to audit in our next explainer. See you in the next kitchen.